Hey, we're going to today solve more problems using sets. We started doing this in the last lesson. We looked at how many people owned a dog, a cat, or a fish, or a combination of those. Today we're going to look at a class of students and what they studied. It's a lot like yesterday, except we're given different information and we're asked for different information. Let's say this is our story. There's 29 students in a class. 19 of these students study art, and art will be our set A. 22 students study biology, and 3 study neither art nor biology. Yeah? And the question is, how many students study both art and biology? So which students are in both classes? All right. This is fun. We have some information already. 3 study neither art nor biology. So where do those 3 students go? They go outside of our 2 circles. That's very logical. Okay, so the question is, how many study both art and biology? That's in here, right? We want to know how many students will fall into this overlap. Okay, we know that the total students are 29. 3 of those are accounted for. So let's see how many students we have left to place. Okay, there's 26 left to put inside these 3 spaces. 26 students left to put on the diagram. The people that study art plus the people that study biology, if that added up to 26, we would know that there's no overlap, right? If the art students and the biology students together were 26, that means there's nobody that studies both. But that's not the case, right? 13 plus 22 is more than 26. Let's see. 19 plus 22 is 41. So 41, that's too much. We only have 26 students to place. And they're like in 41 classes together, right? So there's an overlap. There's going to be, out of these 26 students, there's going to be quite a few that are in 2 classes, right? So if we figure out the difference, 41 minus 26, there's going to have to be 15 students that are in both. There's 41 classes that they were in. There's only 26 students. So 15 are going to have to be, 15 of the students are going to have to be counted twice. Let's write the 15 in there. The total number of art students was 19, right? 19 minus 15 would be 4, so 4 students only study art. Total number of biology students is 22. 15 of those study both biology and art, so how many are left to only study biology? Out of the 22 biology students, 15 study both, so there's 7 left that only study biology. Now let's see, if we add up these 3, 19, 26, they add up to this 26 students that we needed to place. If we add up 19 art students plus 22 biology students, 19 plus 22 biology students, that's this 41. 41 classes that these 26 students are taking altogether. We actually answered the question somewhere in the middle of the problem when we figured out that 15 had to be the overlap between the 2. which was the difference between the total number of classes that we needed to distribute and the total number of students that we had to distribute these classes amongst. Yes, the difference between 41 and 26 was 15. We knew that was going to have to be the overlap. Okay, if you do some of these, this will probably make more sense. I want to show you one other way to answer the same problem. So I wrote drew the Venn diagram again. Also wrote the given information. Again, I just wrote it differently. I said there's 29 students in a class. They're the universal set. 29 students in the universal set. 19 art students, so the number of students in art is 19. Number of students in biology is 22. The number of students that are not in art or biology or both is 3, right? And how many students study both art and biology? What is the number of students in art and biology at the same time? That is the question. Now, this is more of more algebraic way to solve it. We are being asked to find this number. We're going to call that x. X is the number of students that study both art and biology. The number of students that study art but not biology, so the number of students that goes in here is going to be this 19 total minus x, right? 19, which is the total art students, minus x is going to be the number that goes in here. So that's the number. Ooh, I'm going to have to write that down. Number of students in art and at the same time not in biology. Sorry. Okay, the same thing we can say for this side. The total number of biology students, 22, minus x. That's going to be the number of students that are in biology but not in art. Yeah? We can write these expressions in here. 19 minus x, 22 minus x. We know that there are 3 students that don't study either, so they're out here. Plus we know the total number in our set, and that's 29. We can write an algebraic expression because we know this plus this plus this plus that is going to add up to 29. 29 total. Maybe I should do that up here. 29 equals 19 minus x plus x. Ooh, what am I doing? Plus 22 minus x plus 3. Right? I've added up all of these. They add up to 29. And now all I do is solve for x. 29 equals 44 minus x plus x minus x. So minus x. If I move the x to this side, subtract 29 from both sides, I get x equals 15. And I can then say, okay, x is 15, 19 minus 15 is 4, 22 minus 15 is 7, and find all the numbers that way. This is more algebra-like, and I guess this way is more through logic. I think they're both fun. I always do this, but I know that some of you prefer writing out equations and using x. Alright, you can choose whichever way you want to do it, and have fun with it.